Okay, so last time we had our code set up. I think it was what in Q Patient Record Builder is where our actual sample stuff was coming from. We're having it go from. We're building object versions of our cubes, and then we are exporting that to. Then we're exporting that to JSON, and we're printing that out. So we built our room collection, and then started adding some specific rooms to it, giving them their names, giving them their length, width, heights, and then their location relative to, relative to 0, 0 on an axis, even though that's technically living inside of the CS department's room collection, this top level transform. And then we were rotating it. Otherwise, it was building it standing upright. So we rotated the whole thing. And we just printed out the JSON in the end, showing us that this is the JSON representation of what all that stuff looked like. Oh, interesting. Okay, so now I'll go ahead and run this here real quick. And we'll see that the department kind of gets created and we get a bunch of JSON spit out to the screen down here. Okay, and I think that JSON actually looked like what we had put in here, right? Or rather, put here. This is the equivalent to what just spit out. All right, so the assignment for today was to take code that looked like this, take a JSON string, and then turn that guy into the objects that we built last time, right? Okay, how'd that go? Rough?
I think like ours there's string in it, and there's also like quotes.
Mm-hmm.
And like I could get it to like I made a loop that like went through the entire string, but I couldn't get it to like recognize the string.
Okay, but don't we already have a built-in thing that will take JSON and make objects?
Yeah.
Okay, so what was your loop for?
I don't know.
It's a pretty good question. Well, okay, so let's start off with one thing. So I currently have data like this. Now, if I put this in a file and did some file I/O to read it in, I wouldn't have to do anything special. But if I want to paste this string into my code, I'll just demonstrate it here real quick. So I'm just going to create a string here. JSON, and I'll throw double quotes around it, paste that guy in there, say that. Currently, you see it's not happy, right? Why isn't it happy? Okay, a whole bunch of double quotes in there that it thinks are being treated as like string termination characters, right? So what do I have to do to fix that? Well, I'm asking you. Yeah, so you need to do the escape character thing on them to make them look like that, right? So I can go through here by hand and do that, or what I can do is I can maybe just open up like Notepad and paste all that in. Then do a find and replace, and anytime it sees that, replace it with a that. Say replace all. Copy this again. Go in here. hardest part is the scrolling. Now it's happy. All right, so one of the elements there, so that obviously looked pretty easy, right? What I just did. Now, how many of you sat there and put manually put in backslashes? Maybe that would have been your first approach, something like that. Okay, so this kind of goes back to something you probably learned in 150 or 175, hopefully starting in 150, that we have all these different software applications available to us. And whenever we need to solve a problem, we want to consider the resources available to us. This isn't any different than if you're fixing something around the house and you go out to the garage and just see, what do I have available? And you decide to have duct tape and a screwdriver. I have to figure out how to solve this problem with duct tape and a screwdriver. Well, now we have a whole bunch of software applications that we might have available to us. And, Notepad is one of those applications that you maybe rarely use, right? You just kind of, every now and then you need to put something in a text document, but it's kind of fallen to the wayside over the years because we have all sorts of other ways of doing that kind of stuff now. But Notepad was the perfect little tool for that, wasn't it? I just needed something with a find and replace. And specifically something that wasn't going to go and try to capitalize stuff and put formatting into my text. So, 2 seconds in Notepad, and I have this thing done for my tedious thing. Now, down the road, long term, we'd probably prefer to have kind of a file that we can just dump this stuff into, and then read in from that file. Now, if we had a file that we saved this as, then we didn't have to do the backslashes, because when Java would have or C# in this case, when it would have read it in from a file, it would have read in the character double quote, not the string termination or the string starting double quote. Does that make sense? So inside of a file, we would not have had to backslash these. But since we're directly pasting it into our code, we needed it to be formatted this way. So throwing those backslashes in there was important. The longer the JSON, the more tedious that becomes. So you might as well use a tool like Notepad to make it work. Make sense? Okay, so that's starting point. Now I'm going to go ahead and just for the moment, I'm going to go ahead and just comment out all these dudes. Okay. Because ultimately what we want to accomplish here is we want to take this JSON string and turn it into a bunch of objects. All right. Now, if you remember from our room collection here, our toJSON uses this JSON utility to convert something to JSON given this whole object. Okay, what we want to do instead is we want to convert some JSON and have it generate this object for us. Okay, so we're going to have to do that external to here. So I'm going to say I'm going to create a room collection. We'll call it CS department again. And this guy's going to use our JSON utility dot from JSON. And I'm going to tell it the type of class we're going to have. And we've done this previously. We saw this example before. And I'm going to be building a room collection. And then the string I'm going to give it is my JSON string. Like that. Okay. And then just for right now, I'm going to go ahead and print out CS department dot. Let's just print out its name. That should prove that it recombobulated it and then spit its name out. Okay, so I'm going to go ahead and run this right now. Now, ideally, we'd love for stuff to show up on the screen here. Okay. But nothing did show up. Okay, we're going to talk about why here in a second. But notice here, we have, we're getting a oh, there it is. CS department. That's its name. It still had my previous output. So, do I not have clear? Oh, I don't have clear on play clicked. That's why it still had it. But there's the name. So it put back my CS department object just fine, right? In fact, well, let's test one additional thing there. I'll go back into here, and instead of, well, I'll print it out on the second line. I'll say print CS department dot the rooms dot length size count, maybe count. I just had to figure out, how do you ask that collection to tell us how many buckets it has? Some languages it's length, some languages it's count, whatever. So some languages it's size. Okay, now we know that the original we had added 4 rooms. So this should be 4 if it recombobulated it correctly. Make sense? Okay. So we're going to make sure this is saved. Go back and run this. All right, there's our CS department, and there's our 4. All right, seems to be putting everything back together pretty well, right? So the issue is we have our object now. I don't have crap on the screen. Why? Okay, so I think you're onto something here. So let's go back into our code here, and let's look at how room collections were originally built. So inside of our room collection, we passed it a transform, right? Now that transform was private. What does that mean? But when we made these fields private up here, as opposed to public fields, what does that imply about the JSON? That's what these objects, that's what having a private object means. But when we wrote this object with the intention of converting it into JSON, correct? We made all of these guys public because that's what was required to make the JSON object. I'm going to talk about why here in a minute. When we made these guys private up here, we omitted that from the JSON. That makes sense? Now, realistically speaking, kind of, it's possible. I actually want to kind of test this. I'm going to make these guys public for a second, because there's always a chance that when this was originally written, that they wrote game objects and transforms in such a way that they will support serialization. They'll be able to convert them to JSON. I don't suspect that's going to be the case, but I am interested for a moment just to see what those look like. It might even just crash, but I'm going to go ahead and let it attempt to convert our room collection that has this transform and this game object in it. I'm going to let it convert that into JSON and see what it does with that. Yeah, so for room prefab, it gave us this instance ID thing. And for parent transform, it also gave us an instance ID. So there must be one public variable in both of those called instance ID that it just grabbed and said, this must be what you mean from, for creating a JSON object of this. Now, as a human being, if we say, okay, I have an instance ID of 10932, can I use that to recreate my room prefab at runtime? Probably not. That was when we first drug that prefab in there, it was probably given a unique identifier. At the time we ran our program, we can't just store that and expect that unique identifier to hold true in perpetuity in the future, right? Okay, so punchline is this guy doesn't know how to generate those couple of things for us. So we'll switch this back to private, and that's okay. That's what I expected, I expected this guy to act. All right, so we'll flip these back to private. That way they are not included in the JSON. Does that make sense? By having them private, we're saying don't include it in the JSON. By having them public, we're saying do include it in the JSON. But these public variables, we're going to see in a minute the rationale for why they have to be public. You know, up to this point, we just thought, well, they have to be public because the JSON utility said they had to be. Okay, but there's actually a reason they have to be. They have to be public. All right, so let's just quickly look at our room collection here. So when we build our room collection, we're giving it a transform, a game object, and then all these pieces of information, the name, the origins for X, Y, and Z, that stuff. So these are all things that are, you know, valuable pieces of information that we're handing this guy. Now, this X origin, Y origin, Z origin, we're never actually using those values. We're storing them. We're saying this is where we want it on the screen, but we're not actually changing our parent transform to have those positions. We probably should, but we're not actually doing that. Okay, so wherever we put our original game object, so we passed in 0, 0, 0, for example, for this guy. And if we go out here, we go to our CS department before runtime. Oh, he does happen to be at 0, 0, 0, but I'm going to go ahead and change this guy to like a 2, 7, 4, something like that. Not at 0, 0, 0. Okay, and I'll go ahead and just run this again real quick. And notice that the CS department is still at 2, 7, and 4. Okay, so we're never actually using those values to reposition our CS department somewhere in the scene. We just happen to be storing those pieces of information. Make sense? All right, so if we wanted to make that piece of it a little bit more complete, a little bit more accurate, what we would probably do here is we would probably set our room prefabs, our game object. We would probably set our parent transform. So this dot parent transform dot transform. Let's see. I probably can just set position directly. Dot position is equal to a new vector 3 of. I'm going to change it to this origin, this dot y origin, this dot z origin, and I'm going to move this line down because we're technically not setting those things until the very end here. And I'll show you why I did that in a second. And this wasn't required for the homework assignment. This is more just we technically didn't ever use those values. We were storing them, but we didn't use them. These guys are coming in as doubles. Of course they are. So I need to, we had the same problem last time, right? So I need to just convert them to floats. Okay. So we have that. And now let me just show you. So all I've really done there is done this one line, right? Just added one line here. And now what I'll do is when I go back in here and run it, CS department starts off at 2, 7, and 4. Now when I run this guy, notice it moves to 0, 0, 0, which was the X, Y, and Z origin that I passed in. Make sense? So I physically bumped that guy over based on the origin where I wanted the CS department at, regardless of where this guy was originally placed. Make sense? Everybody's cool with that at this point? All right. So not part of the homework, more of just we had 3 variables that were effectively just for show. they happened to work before because we just happened to have our CS department transform at 000. So the two numbers looked the same, but they were never actually used together. Okay? All right, but regardless of that, our constructor here, this guy, is the guy that took in a parent transform, room prefab, and then all these other individual pieces of public information, right? Now, we know that in that JSON, we are not, because we had it stored as private, we are not storing our transform or our game object, correct? We know those guys are not getting stored in there. So we then know that this constructor for room collection is not getting set. It's never getting called. This version of room collection is never being called. What's actually being called it's effectively this. Because we had, let's see, I think I could probably give us a fake object of this type. See, it's having to do it with generics. So what it's really probably doing is this. What does an object need to be built with? So we have an object, and then can we say room collection? Oh, it doesn't like us implicitly converting it to that. I'm trying to recreate what it's doing behind the scenes. Effectively, what it's doing, I'll just write it first, and then we'll maybe look at it for a second. It's attempting to create an empty room collection. Okay, a room collection using a no argument constructor that takes no parameters. That's what it's attempting to do. Now, this constructor would exist had we not written our own special constructor for this. So this code would actually not be an error under other circumstances. Right? But as it's written here, it is an error. There's probably a way in C#, let's just Google it real quick. Well, let me just prove something first before we go any farther. What I'm going to do is inside of room collection here, I'm going to print here. Oh, this is a mono behavior dealy, so I need to say console dot write line. Oh, it's also not part of it. I want to print something in there proving that we don't get into this constructor. So I guess for right now, you just have, I could make it work, but it'll just take 2 minutes to do something that we're going to undo anyway. So just trust me when I say we're not getting into this constructor. This constructor is not being called. It doesn't have the information to call it. Instead, what it's actually doing is creating an empty version, like an empty husk version of this class. And then it's setting that guy CS department2.name equal to CS department, or whatever we had done, whatever the JSON says it should be. Okay, so that JSON utility is going through and it's parsing this giant JSON string, pulling out the bits of information, and then setting the public variables of a room collection equal to those. Does that make sense? Now, what it's possibly doing is it might be grabbing the empty, or it might be grabbing the information about the constructor and maybe passing it null values for all the inputs, and then maybe passing it zeros for any numerics. So now it effectively has a useless version of room collection, right? That's what this guy has right now, is a useless version of room collection. And after that, it can set only the public variables. This is why those guys had to be public, so that it could directly access those variable names, those field names, from the instantiated object, rather than ever call a constructor. All right, that part makes sense? This is just how it accomplished the to JSON and from JSON dealio. Really, they needed to be public for the from JSON piece to work. Okay, so I'm going to go ahead and show something else here then, or prove something else here. So I'm going to say print CS department2 dot, I need to make it public. So I'm going to go ahead and say public game object get room prefab. So I just gave myself a little public getter that I could use to ask for that private variable room prefab. And let's see what value that has. My contention is that it's going to have or suspicion is it's going to have the value null. All right, so this guy's still private. I don't want to make it anything other than private, otherwise the JSON thing won't work. But we know that when we recombobulate this thing from JSON into an actual object, that these two private variables are not being set. So I'm going to go ahead and grab that variable after we recombobulate it and prove that it's not being set. So I'll print CS department dot get room prefab. All right, so we're putting it together. Actually, let's do it the right way up here. All right, so I have my JSON string. I'll build our CS department using the JSON utility. I'll go ahead and print the name out like we've already seen work, but then I'll also print out the room prefab. I'm indirectly getting it using a public method rather than the field itself, because the field itself is private. And I expect this guy to be null or something similar, be a nothingness value, showing us that that constructor is never actually being called. Yep, so there's null. This is the reload solution thing. So this guy's null. So that value is never getting a value. Therefore, our constructor is either A, never being called, Or when it is being called, it's being called with generic empty values just to give us an instance of the object. And then that instance of the object is being publicly modified through its public variables. But we're never actually getting the those two kind of important pieces. Does that make sense? So what does that ultimately mean? If we go back through our code here, when we originally built our room collection, okay, we gave it a transform, a room prefab, and then some location stuff. And then we repeatedly called this add room function that added our 4 different rooms. Now, we've already seen that after we have, it's called marshaled this, I've been saying recombobulated because it's more fun. After we've recombobulated this JSON into a room collection object, we've seen that the rooms has 4 rooms in it, as if these 4 functions had been called. But those 4 functions have not been called. How do we know? Well, what happens when we call those functions? When we come down here and we look at add room creates a new instance of room, which is being created, but it's being created in the same way that our room collection is being created. We don't actually have a parent transform. We don't actually have a room prefab. Well, at this point, we don't actually have the name for this particular guy, the length or the width. So it's creating this new room constructor with nothingness inside of it. But notice that what this constructor does is it creates a new room game object using instantiate with a null value. So it's not actually getting a real instance. And then it's not actually setting the parent. Well, it is setting the parent. It's setting it to null. And then setting the position of that guy to something real, the position of something else to something real, and so on and so forth. Okay, we actually kind of know that this code is never actually being called because these would throw errors if it was. Okay, so C# must have an alternative way of creating a generic instance of a variable without calling the official constructor that we have. However, I'm sure we can Google it and figure that out. But regardless, that's what's happening under the hoods. We're getting an empty husk of a room that is filled up in our rooms array. But then what we're doing is we're going through and we are setting the public variables of that instance to the name, the length, and so on and so forth. All right, we can prove that up here. By printing out the rooms dot get, let's see, they're just like a first thing. This will work. I could do it this way. ToArray dot bucket 0. ToArray dot, and we'll get this guy's name. So I'll go ahead and just grab the very first room that's in there. I'll grab the name of that very first room, which should be 1. So let's see if 1 prints out there. That tells us that it did indeed build those rooms. There's our 1. So it built those room objects with the public values that we had in our JSON. But we still have nothing actually to show on the screen because we never actually gave it the transform or the game object. Make sense? So what we have right now is we have an object with all the information we need in it, but it hasn't done its magic. That required the transform and the prefab to do. It hasn't done that piece yet, right? So we're going to have to add some logic into these classes to say, okay, we realize that you were kind of just brought into existence in kind of a non-traditional way from the JSON thing. Now we need you to go ahead and build yourself back up in the way that you were supposed to had we built you in the traditional way. And in order to do that, we're going to have to provide it with those two pieces of information. Okay, so I'm just going to write a little function in here. I'll go ahead and remove this get room prefab. That was just for our little testing. So we'll create a public variable. We'll say void, and we'll call this post from JSON, I don't know, setup or something like that. All right, and this guy's going to have to take our room prefab and our parent transform. So it'll take those two pieces of information, and then the presumption is when we're in here, we already have a room array filled up with all of our rooms. We just have to go through and ask each of those rooms to do its magic. Okay, so for the moment, I'm going to go ahead and set room prefab equal to room prefab. And this dot parent transform equal to parent transform. Okay, so just since those guys didn't get initialized as part of the original pass on the constructor, we'll go ahead and set them now. That makes sense? They were private. We didn't get them from the JSON, so we'll set them now because we do have them. All right, then we need to go through each of our rooms. So for, do I have a for each in this? Okay, so for each room R in this dot the rooms. So we'll go through our list of rooms, and we want to tell each room to go ahead and generate itself. Okay, so now we need to go teach rooms how to do that, and that's where we looked at add room before. So add room, when it created a brand new room, got all of his public information set. Well, almost all. So he got all of his public information set, but he doesn't have this private information. Okay. And he didn't have enough information to do all this stuff. So what I'm going to do is I'm going to take that little chunk of code there, and I'm going to move it into a separate method, and then call that method from here. So I'm just going to cut this, and we're going to create a little public method here called public void generate physical room. All right, and this guy is going to take in a game object, room prefab, and it's going to take in a transform, parent transform. And I'll go ahead and paste the code that I just stole here. But I'm also going to go ahead and steal these first two lines. We know they're not being called through the regular constructor anyways, unless we're the one who called the constructor. So I'll remove them from there. But I'll go ahead and paste them in here. So whenever this function gets called, it will set the instance room prefab and parent transform, and then actually go and build an actual room that will show up on the screen. That makes sense? Now, we want this to occur in our normal call to our constructor. Okay, so we haven't changed any of the code. We just moved those lines into its own function. And then when we normally call our constructor, we'll go ahead and call that function because that function does what we want it to do. Similarly, now that I have this public function that goes ahead and hooks up our room prefab and our parent transform and then generates our room, up here in my post from JSON setup, for each of these rooms, I can tell the room to generate physical room, passing it my room prefab and passing it my parent transform. That makes sense? And I can do a pretty similar thing to what I did. Well, actually, I'm going to need these guys up here for this. So I can't move these guys out of here because if we are the humans creating a room collection, I'm going to pass it my room prefab and my parent transform. And these guys are going to be used by add room to create that new room. Where this is kind of a special thing that we only are going to use after we generated our array of rooms from JSON. Because effectively, when we create our array of rooms from JSON, we never went through this process of creating a new room, passing it transforms and prefabs. Instead, we just got all the information for the room objects and had them thrown into that list inside of our room collection. And that those rooms never were actually created. So now I just have a nice little function I can call after my guys were created, after my JSON generated these objects, where I can pass it the room prefab and the transform, have it go ahead and set those couple of guys, and then go through all of my rooms and tell each room to generate the physical version of itself. That makes sense? So then back in here, all I have to do then is after I have created my CS department, I can say CS department dot post from JSON setup. And this guy expects me to pass it a room prefab. So this dot room prefab and a parent transform, this dot what do I call it? Game object transform. So there's the parent of it. So this is the game object that this particular script is attached to. So really all the logic we had to do was here's our JSON doctored up. We'll go ahead and build our CS department using our JSON utility. Then we have to call this extra function that we had to write that went ahead and gave our rooms a reality. Go ahead and run this guy. Big money. I clicked, didn't I? There we go. I clicked better this time. And now we see we actually have a version of our code, right? But it didn't do the rotation thing. So we just need to toss our rotation thing into that post JSON setup. This was our little transform guy here. We'll go into room collection. And at the end of this guy, It's actually the parent transform that we're going to rotate. We'll rotate that to 90 degrees inside of there, since we've decided that's what's required to get it not standing on its, I don't know, head or feet or however we want to look at it, however you want to look at it. All right. So since we had to rotate it before when we did it by hand, now we need to have it rotate when we do it by so there's our top-down view of it. All right, so it built it for us. That makes sense. So let's review what we had to do to accomplish the assignment. So this goes back to this whole saying that all hard programs are made up of a bunch of easy parts. Okay. Now, most of what we talked about today was kind of explaining how this JSON builder thing works underneath the hood. JSON utility works under the hood, right? Wasn't required that you understood that to do the homework. Okay. But perhaps through some experimentation, you would have come to some reasonable conclusions about how it worked. So the first part of the assignment was these two lines, right? Here's my JSON. Build me, use JSON utility to go ahead and build me my CS department object, my room collection object. Okay, so now I have a room collection object that has all the data from the JSON in it, but hasn't performed any of the logic. Now I need to go ahead and tell it to do the logic to get it to actually show up on the screen. So what did I do? And inside of room collection, I wrote this function, where I went ahead and I let this guy know about the room prefab and the parent transform, those two private variables that would not have gotten set by the JSON, right? Those guys were not included in the JSON. I only have access to those guys at runtime. So it wasn't until my code was actually running that I would have actually had the room prefab and the transform associated with the game object that the script is attached to. So it was at that point in time, I went ahead and said, okay, I already built my data-based room collection object, but I haven't actually gotten rooms up on the screen yet. So I'm going to go ahead and have this extra little function. I'm going to pass it my two pieces of information that I now know at runtime, okay, that I couldn't rely on JSON remembering. And I'm going to go ahead and I will tell my room collection about those two private variables that it did not know about from the JSON. And then I'll go ahead and go through all of my rooms that the JSON did build for me, but never actually got on the screen because it didn't have those important pieces. And I'll tell each of those rooms to go ahead and generate a physical room, passing it the room prefab that it needs to build a version of itself, and then who its parent is. So if we look down in room, what does generate physical room do? It goes ahead and lets a room know about those two pieces of information because it didn't get those set before, because those are private variables inside of here. Just like before, we had those two private variables. Now, the reality is, as we're using it right now, we actually never need those. We only need the room prefab and the parent transform at the moment that we are creating those rooms, right? We don't actually need them at a later point in time. So I probably didn't have to make these guys private, since when we normally create a room, we have the two local variables. And in this case, when we are post-generating the physical room, we're passing it those two local variables. As our logic says right now, we never actually use these two variables anyplace else in the program. But we might. All right, so you can make an argument whether you want to store them for later use or not. Probably if you're going completely by the book, since we don't currently have a reason to use them outside of this function, we probably would not want to store them as fields, and we would not want to have to set them here. We would just use those local variables. That makes some sense? That's more of like what's good programming practice. as opposed to, you know, in this case, who cares? I might need them later, so I'll just set them. All right. But bottom line is, I get these two pieces of information here, and then what do I do in this generate physical room? This is the part where I actually generate the game object that shows up on the screen. I create a game object using instantiate with the room prefab. I set that dude's parent equal to the parent transform, and then I set his position and his local scale to the pieces of information that are already stored inside of the room. Okay, so this function here makes our room physically appear on the screen when it was built from JSON before, when we didn't have the ability to physically generate it on the screen. This guy here goes ahead and lets our room collection know about the two pieces of information it needs to physically have stuff show up on the screen. And then he goes through all of his rooms and tells each one to now go ahead and generate yourself. And then finally, it just does our little rotation. So two relatively small functions and these two lines. Oh, really, these three lines, as we technically have to call that function. That makes sense? So not a whole lot of code, but kind of important code that we needed to put together some pieces to get this guy working. Make some sense? Okay. So some lessons to learn from kind of that approach. Whenever you're solving a problem, okay, a problem's presented to you, what's the first step in solving a problem? This goes back to 150. Okay, then understanding it, right? So you got to understand the problem, right? So we're going to understand the problem first. So in real life, you can never solve a problem that you don't understand. Is that a true statement? Okay, you got to understand the problem before you can even start solving it. Okay, so we have to understand the problem first. Okay, then we got to start formulating a solution to that problem. This all happens way before code. Now, in this case, I wanted to show you all these details that are happening under the scene with the JSON. Okay, but when you first ran this, so I would have expected for the homework, you should have been able to come up with this and this line pretty easily, or something similar. Okay, probably not going down the route of creating a for loop to parse through the JSON, especially since we'd already shown the from JSON example in class, but you know, you probably had a fun couple of hours there, I'm guessing. And frankly, that's where the most learning takes place. All right, but punchline is these two lines should have been comfortably within all of your wheelhouses. Right? We had done examples of these before with a smaller thing. So we needed our JSON string. We already had one created. You know, you should have recognized that you had to do the escape characters on the backslashes here, or on the double quotes rather. We had done that before. And then finally, we'll just call JSON utility to go ahead and create from us a from JSON. From our room collection, we talked about generics. We didn't go into super detail about the purpose of generics and stuff, but we certainly talked about this syntax. And if I'm building a room collection, that's what I need to pass this guy here, because that's what JSON utility says I have to do. All right, you don't always have to understand all the inner workings of the object to get something to work. We've spent today's class talking about some of those inner workings, but it wasn't required for the homework. All right, so these two lines should have been comfortably in your wheelhouse. From there, you would have recognized that when you ran it, no errors, everything was good. You ran it, but nothing's on the screen. Crap. Nothing's on the screen. So then you ask the question, why? Why is there nothing on the screen? And that's when you would have started to do some investigation. Okay? You would have started looking into, okay, well, what's actually getting called, what's not getting called. You know, you saw here today, we printed out the value of our game object. So, you know, recognizing that the only information, I mean, you know, the proof is in the pudding, so to speak. And we come in here to our JSON. Here's our JSON. We see that nowhere in here do we have, my phone's just exploding. Nowhere in here do we have a collection. Oh, nowhere in here do we have the information associated with our game object or our parent transform, right? Those guys didn't come with this chunk of JSON, and the reason why they didn't come with that chunk of JSON is, well, why is it? Why didn't those guys come with a chunk of JSON? Let's see what we learned today. Yeah, because we said it was private. So by flagging it as private, they don't get stored with the JSON. They won't come back in with the JSON. Okay, that's the problem. Make sense? You have to understand the problem. So it wasn't contained in our JSON, so it would be realistic for us to recognize that, oh, it wasn't in there, probably isn't in our created object either. Okay, it never passed that stuff along. You could have done some experimentation, printed out some pieces of information, ultimately proving that to yourself, like we did in class today. But you could have also just speculated that, hey, that might be the problem. Okay? Because then you make the additional connection where you say, all right, well, when do I have my room prefab and parent transform? Well, this goes back to how does Unity work? Well, with Unity, I have this empty game object we created in here, and I attached this script to it. I had to let this guy know about that room prefab. So not until this script actually launches do we have access to those two pieces of information. Now, that JSON existed before this script launched, didn't it? Yes, we had it on a slide. Okay, so right now the script doesn't exist. Now I click, the script has launched. Yet the JSON has been on that slide in our thing since last Thursday. Make sense? So JSON existed before these objects existed. So clearly that JSON was not going to generate these objects for us. So that's when we had to say, I need to do a little bit of extra work. I need to doctor that object a little bit more so that I can actually get that stuff on the screen. Okay? Now, in that investigation, you maybe would have stumbled upon the idea that, oh, wait a minute. You know what? I bet you this guy did not get called. Okay? Less important for this one because at a glance, if we're looking at room collection, potentially this guy could have gotten called and these two values could have been set to null. That's potentially possible. But if you would have looked at the room constructor, which we have changed a little bit now, remember that this code used to be in the room constructor. Well, all of this code was. Okay, all of this was in the room constructor. And notice that down here, we are trying to use mono behavior to instantiate something that we did not have yet. That would have been problematic. Probably would have thrown an error. Similarly, we're trying to set a failed instantiated room's parent transform equal to a null object. Similarly, we're trying to set a failed instantiation of a room object's position to, we did have this information. so at least now we're starting to get to stuff that we have, right? We did have the X, Y, and Z because that was stored in the JSON. We also had the length, width, and height because that was stored in the JSON. Make sense? Okay. So it should have been fairly obvious to us that this constructor was not getting called because this code right here that used to be in that constructor would have blown up. I didn't have that data. Okay, and that's where you would have discovered the second part of your problem. You knew there was a problem. The second that you didn't see stuff on the screen, you're going to say, there's a problem. Why am I not seeing this stuff on the screen? And that's when the investigation would have started. Make sense? That was the hard part of the assignment, is going and figuring out how do I fix that. All right, does it make sense how we did it now? That you've seen it? And that's okay. I mean, that's the point, right? And we see that, and this kind of goes back to the statement I made a few minutes ago, that all hard programs are made up of a bunch of easy parts. None of the code we wrote was overly complex code. But we had to know that, oh, this is what's going on, and this is the code I have to write to fix it. That makes sense? Pretty commonly, you're going to see, when you're learning the program, you're going to see, when you see the solution, you're going to be like, that was it? Something like that. That's a pretty common experience, right? Because you sat there for 6 hours staring at something, writing dumb loops. But, you know, that's... I wish I could have been a fly on the wall there. Why is this guy writing these loops? But I'm 100% positive at some point when I was first learning programming, I was doing the same kind of crap. So eventually this stuff will become more obvious to you. All right, so these were the hard parts of the program. So if you didn't quite get these pieces zipped together, don't feel too horrible. You know, that's the, that was more the computer scientist side of things, making these leaps. So as long as you understand it now, that's what's most important. If these two lines were lost on you, that's a bigger problem. These guys should have been doable or close. You know, maybe your brain fart was that the backslashing of these guys wasn't just, you weren't aware that's what you had to do. We're going to call that in the realm of okay. You know, that happens once or twice to you during your career. You learn pretty quick that, oh, I have to backslash double quotes because it won't work otherwise. Okay, whatever language I'm looking at is going to treat those as string termination characters, and that's not my intent. Make sense? All right, so if that's the only problem you ran into, if you pretty much knew you had to do this and you knew you had to do this, but you couldn't get this to work because you didn't doctor this guy appropriately, we're going to call that you're in the realm of okay. All right, but these two lines should have certainly been in your wheelhouse. The other two pieces would have been like kind of the challenge you at the maybe just out of reach, you're kind of touching the edge as you're falling off the mountain or something like that. I don't know why I just thought about this. This would be really fun. I think it was the falling off the mountain thing. But you've seen that show, like American Ninja Warrior? You know what show I'm talking about? And I mean, I think they've done spoofs like this before, like on Saturday Night Live or something, where you have like just like a really, really like fat guy, right? Like he's at the starting line, and you just know this guy is gonna fail. Like he might, like if I did American Ninja Warrior, I think I have maybe a 50-60% chance I could get through that initial thing where you have to run across. I think I'm shockingly nimble for my size, and I have pretty good balance for golf. But after that, I can't do a pull-up, right? these guys are doing constant. I mean, well, hey, look, if any one of you had the rest of me, I don't care how strong you currently are, that's 380 pounds you're pulling up. Okay, so none of you could do a pull-up if you were me either. is the punchline. But I mean, you know, the stuff they have to do is ridiculous, right? You know, and if you're super fit, then you know you might be able to get through portions of the course before you get fatigued. Yeah, but I'm not getting through, you know, whatever number 2 is, right? You know, even with full energy. That's it. But wouldn't it be funny if you like were watching the show in real life? Because I think anybody can go and try out, right? I don't think there's like that would be a kind of a funny hidden camera type thing where you just show up and you're waiting in line. Okay. Oh, like that?
Yeah, like he pushed somebody off of like their starting position. He ran the course. Everybody was trying to get him off.
Well, so here's the question: which is more embarrassing, doing that and completing it, or just being a fat guy fully clothed and not? But that would be a pretty funny hidden camera thing if you're like hanging out in line, because I assume the original tryout line's probably pretty long, right? You know, you might be there for 4 or 5 hours or something like that. And, you know, everybody around you just knows you're not getting through. It's almost like the America's Got Talent show where, you know, somebody's just, you know, they don't have talent. you know. but in this case, you like really know you're not getting through, guy. But then you dress, you know, like you're like, I don't know. You can either go crazy and just be like full spandex or something like that, like, or you could like dress like you're like a legitimate competitor. You know, like in golf, you got people that you know, most people are not very good at golf. So, but you have most people that you see go out in the golf course and play when they're like, you know, playing with their boss or something like that. They dress like they're going to shoot under par, and then they don't break 100. So they look like a legitimate golfer, but they're not. So you can dress like that. You can dress like a legitimate competitor, and then just totally not be one of those legitimate competitors. Maybe I should do that this next year. It seems like it would be a really funny hidden camera time.
Probably just stand in line on TV.
Think about this conversation. You remind me next year we're going to do this. Okay. I might not even start the course. I don't want to hurt my knee. I got bad knees, but I'm only cost myself about 40 feet. But just the whole thing of standing in line, and you know, I could just be doing all sorts of stretches instead of kind of keep myself loose. Maybe if the thing was like on the moon,
Yeah.
I might be able to have a shot. I probably wouldn't do it very fast though. So now I'm going to have a problem with the speed. I could do a pull up on the moon, I think. Does that mean anything? Okay. So any questions about this guy? Makes sense how it's working now? Okay. So on the final, and we'll review for the final on Thursday, but let me give you the 2-minute elevator pitch for it. JSON will likely be represented on the final one way or another. You probably would not have to. The stuff we learned today could be represented on the final, but it'd be represented in like the form of a question of like, why might we need to do some additional modification to our objects even after we rebuilt them from JSON? Kind of this idea that we didn't have access to our game objects, we didn't have access to those things. More the top level knowledge of that than writing code to do it. That makes sense? But certainly you should understand, like if we gotta go back, and we'll flip through our slides in detail next time, but the last couple of weeks we've been really working with this data representation type stuff. I would expect this stuff to be, you know, represented somewhat heavily on the exam, the stuff we've done recently, because, you know, you think about stuff up to the midterm, a lot of that is more Unity fundamentals, right? And then the stuff we've kind of done since there has more to do with the modern nature of games, and that most of our games today are going to be network-based games, and we're going to send data over the network representing things and that kind of stuff. So understanding this idea of protocols and you know, I might ask a question about RESTful APIs. We'll go through these slides next time, and I'll really think about it. But certainly have an understanding of this idea of data representation languages that we talked about. You know, this is a pretty important concept across all computing. But when you think about the percentage of games that are network games, there's a lot of data that's being passed across the network and has to be passed in some sort of format that, you know, like if him and I are playing a game and when he moves on the screen and my client needs to update that he moved on the screen, that data had to get to me somehow, right? And it went through a server, then was broadcast out to all the other players in the world. And I had to get all that information about, you know, where he is, what's his current position, is he crouched down, stuff like that, you know. All sorts of things like that. You want to think about how's that data actually represented, and it's going to be represented in a newer game, probably in JSON, older games in XML, but in old games, like kind of our early network games, probably in like a proprietary format that would have only worked for that game. All right. Questions? So between now and next class, maybe go through the current slides. They're up on Blackboard. See if there's any things that you want me to cover again on Thursday. On Thursday, we'll go through the slides one by one. I'll tell you what things I feel might make an appearance on the exam, what might not. When is our exam? I already have it on my calendar, but just make sure I tell you right. So, bright and early. Thursday at 7:30 a.m. Yeah, that should be fun.
Are both of ours on Thursday, or do we have? Is that
250 is on Tuesday at 10:10. 325 is Thursday at 1:10. Yeah. All right. Plenty of room, front row of chapel. I'll save a seat for you. Also, today's student, faculty, staff Bible study, the last one of the semester, God and Grub. Just go to the cafeteria at noon, sign in, get your free lunch, take your tray down to the terrace room. I'll save you a seat at our table as well.